Hey, what's up, everybody? Today, what we're going to be doing is 9.6, which is talking about the natural base E. When I'm saying natural base E, what I'm referring to is if I have log, and then if I have a base of E. And E is an irrational number, kind of like pi, it goes on forever and ever and ever. So let's talk about a couple formulas. We don't really need to know about this. We're going to focus more on this formula right here, the compound interest formula, which is a better version of that formula I just had up on the screen. So this A is going to be our final amount. This P is our initial amount. This R is our rate. And we are going to have this rate as a decimal. Normally it gives us an interest rate as a percentage. We have to convert that into a decimal. N is the number of times per year something is being compounded. And this T is time, and as in number of years. And this stuff is actually important because a lot of times you guys ask, oh, when are we ever going to use this in everyday life? Well, this is something you can actually apply to everyday life. Your final amount, your initial amount, your rate, number of times per year, and the number of years. This will tell you how much money you can actually get from an investment based on a certain interest rate. And they actually use this formula too when you are buying a car. So the finance guys will like figure out the loan and stuff that you need using this formula. So it's actually pretty cool. All right, we have number one. Well, I should go back and explain this formula. So our final amount, we take our principal amount, our initial amount, times it by the quantity 1 plus our rate divided by number of times per year, all raised to the exponent n times t. So number one, we want to determine the amount of money in a money market account if an annual rate of 5% compounded daily if Marcus invested $2,000 and left it into the account for 7 years. Whew, that is a lot to unpack. What I'm going to do is I'm going to highlight some things. When you see the word compounded and it's actually being specific and it's saying daily, well, daily there's 365 days per year, so n is going to be 365. If I said weekly, that would be 52. If I said monthly, it would be 12. If I said yearly, it would be 1. Okay, 7 years, he leaves it in the account. He starts off by investing $2,000 and the rate is 5%. So let's kind of plug this in to our formula. I'm going to have A is equal to our initial amount, 2,000, times 1 plus our rate is 5%. Well, as a decimal, I'm actually going to put this in parentheses. 0.05 divided by n, the number of times per year is compounded. It's compounded daily. There's 365 days in a year. I'm going to close that parenthesis, and then because it's just talking about this and this, I have to close this parenthesis now. And we are going to raise that to n times t. So parenthesis, n is number of times per year, 365 times number of years, 7, close that parenthesis. And we're going to take this and we are going to put it into our formula, into our calculator. So let's do that. Calculator, clear that. We got 2,000, parenthesis, 1, plus, I'm going to close that parenthesis, 0.05 divided by n, 365, close that parenthesis, close the whole parenthesis, raise it to parenthesis 365 times 7. Close that parenthesis. So there's a lot of parentheses. Please make sure you're keeping track. Press enter. And because we are dealing with money, we have to raise it to the nearest cents, so 2 decimal places. So our amount that we get is $2,838.07. So that's saying, hey, if we put $2,000 into some account and just leave it there for 7 years, we're going to make 838 bucks off of interest doing nothing. We're not touching that money. We're not doing anything with it. We're just leaving it there. So it's actually pretty cool. All right, let's talk about the natural base E. All you need to know with this is that it's an irrational number. That's all you need to know. You don't need to worry about it being factorials or anything like this. You just need to know it's an irrational number. And we use this when we see the word continuously. If you see the word continuously, you are going to be using this equation coming up. So the last equation we used, this compound interest formula right here, is when it was compounded a specific number of times. This one was compounded continuously. And the equation is A equals P times E raised to R times T, also known as PERT. I like to say PERT because PERT sounds like something Cardi B would say. And every time I hear Cardi B, I feel like it's continuous and it is never going to end because she is freaking terrible. Cardi B is made for those who think because they're getting louder in an argument, think they're winning. Anyway, A is our final amount. P is our initial amount. So kind of the same thing as last time. The letters mean the same thing. R is our rate, and we always write our rate as a decimal. And T is time, and we refer to that as number of years. So number 2 is saying, hey, find the balance after 25 years of a $10,000 investment earning 6.75% interest compounded continuously. All right, so we are going to highlight a couple things. I'm going to highlight blue this time. When we see the word compounded continuously, that means we have to use PERT. This continuously means PERT. Okay, 25 years, starting off $10,000 and a 6.75% rate. So let's plug the stuff into our formula. Our amount is equal to our principal amount of $10,000 and then E, and we are going to raise that to parenthesis. Our rate is 0.0675 because I got to move a decimal place 2 places over to create a percentage into a decimal, and then times number of years, 25. So just like last time, we're going to plug this into our calculator. Open up the calculator, and we're going to go 10,000. And then E, to get E, we press second, and the E button is this LN. It will give us E, and it will automatically raise it to an exponent, which is pretty cool. Close, open up that parentheses, 0.0675 times the number of years, 25. Close that parenthesis, press enter, and we get $54,000, $54,059 round to the nearest penny, 49 cents. So let's write that. Our amount is equal to $54,059.49. So literally by doing nothing for 25 years, we just put money into account, just let it grow. We do nothing. We get almost $44,000 in interest by just doing nothing. That's a pretty sweet deal. So if you can go to a bank and see, hey, it's being compounded continuously, pretty cool deal. And a lot of this stuff you can actually do right now. If you go to a bank, you can open up a CD, which is known as a certificate of deposit, put money in there, and don't touch it for a year, and you make a couple $100 off of it. So it's pretty cool. And this last thing is Half-Life. Honestly, I really don't want to do this. I feel like it's a hard topic to do. I really don't want to do this over online. So we're really not going to worry about it. I think this is way better to do in person. So we are not going to worry about it. Please let me know if you have questions. Please feel free to stop in during office hours on the Zoom that I post on Classroom. It really is helpful. I can promise you that PhotoMath cannot do this stuff for you. It's not going to be able to do it. So please let me know if you have questions.